Hey everyone, and welcome! Today, we're going to tackle a single but incredibly powerful Java keyword, abstract. Now, it might seem small, but trust me, understanding this is the key to solving a super common design headache and building code that's not just functional, but flexible and built to last. So let's start with a classic programmer's puzzle. Imagine you're designing a system. You need to make a rule. You need to guarantee that every single object of a certain type has a specific feature. But here's the catch. You don't know how that feature is supposed to work just yet. So how do you do it? How do you force a feature to exist without actually writing the code for it? Well, that's the exact problem the abstract keyword was designed to solve. Here's our game plan for today. We're going to start by looking at that common programmer's problem. Then we'll see how the abstract keyword swoops in with the perfect solution. After that, we'll learn the essential rules of this blueprint, see how to make it real with some actual code, and then we'll wrap it all up with the key takeaways.
Okay, let's set the stage. We're going to walk through a scenario that pretty much every developer runs into at some point. So let's say we're designing a very generic car class. We know, by definition, any car has to be able to drive, right? But maybe at this early stage, we haven't figured out the complex engine logic for the drive method. We just don't know how it's going to work.
So what's the first thing many of us are tempted to do? We just leave the method body empty. Just put in the curly braces and call it a day. And guess what? Java is totally fine with that. The code compiles, no errors. But this is a trap. It's a really dangerous one because it means someone, maybe even you in 6 months, can create a new car object, call the drive method, and absolutely nothing happens. You've basically created a car that pretends it can drive, but it can't. It's a broken promise right there in your code. And this is exactly where the abstract keyword comes in. It's a much more honest, much more powerful solution. It lets us define a contract, a kind of blueprint, for what a class is supposed to do. So what is an abstract method, really? It's basically a method's signature, without any of the work. You don't get the curly braces, you don't get any code inside. You're just declaring that this method must exist. Its whole purpose in life is to be a placeholder, forcing any class that inherits from this one to provide the real implementation. Okay, look really closely at this change. It's subtle, but so important. The problem was that empty method with the curly braces. The solution? We get rid of the braces, replace them with a semicolon, and add that magic abstract keyword. This tiny change is a game changer. It turns a misleading, empty method into a powerful declaration. The code now screams, hey, if you want to be a real, usable car, you must provide your own definition of how to drive. And that brings us to the perfect analogy for this whole concept. I want you to think of an abstract class like an architect's blueprint for a house. The blueprint clearly states there must be a kitchen, there must be a bathroom, but it doesn't contain the actual bricks, the actual pipes, or the wiring. It's the plan, not the house itself. Now, you can't just sprinkle the abstract keyword wherever you feel like it. Java has some pretty strict rules you have to follow, and this is the part you absolutely need to nail down, especially if you're prepping for a technical interview or an exam. These are the rules of the blueprint. Let's walk through this one by one. First off, if your class has even a single abstract method, the whole class has to be marked as abstract. It's like a chain reaction. An incomplete part makes the whole thing incomplete. Second, and this is so important, because the class is just a blueprint, you can't actually build it directly. Trying to say new car will give you a compile error. And this is great. It's a safety net that stops you from ever creating broken objects. Third, an abstract class can be a mix. It can have abstract methods, which are just ideas, and regular, fully coded methods, like a play music feature that works for all cars. And finally, here's a tricky one that loves to pop up on exams. A class can be declared abstract, even if it has 0 abstract methods. Why? It's a design choice to stop anyone from creating an instance of that specific parent class. This is the big question, right? If we can't create an object from our blueprint, how do we ever build the actual house? Well, the answer lies in one of the core principles of object-oriented programming, inheritance. So this is where we finally get to start building. We take our abstract blueprint and use it to create real, working objects. And we do this through specialized child classes, which have a special name, concrete classes. A concrete class is the actual house built from the blueprint. The name says it all. It's solid, it's real. It's a class that inherits from our abstract class and, this is the crucial part, it provides the missing code for every single one of the abstract methods it inherited. Once it fulfills that contract, it's considered complete and you can finally create objects from it.
So let's go back to our example. A wagon R is a specific kind of car, right? So we create a wagon R class that extends our abstract car blueprint. By doing that, the wagon R class is now handed a mandatory job. It has the responsibility to provide the actual code for the drive method. It has to fulfill the contract that its parent laid out.
This comparison just lays it all out perfectly. The abstract car is the concept, the blueprint. It declares that drive must exist. The concrete wagoner is the real-world product. It actually implements drive calling. The parent class forces the rules, and the child class has to follow them. It's a beautiful system. Okay, now for a really important edge case. Let's say our car blueprint also had another abstract method, like enable autopilot. But what if our wagoner class only implements drive and just ignores enable autopilot? What happens then?
The rule is simple, and it's totally logical. If the subclass is still incomplete, if it hasn't fulfilled the entire contract, then it must also be declared abstract. The responsibility to implement the remaining methods just gets passed down the chain to the next class that inherits from it. This chain of abstraction can continue until finally some class implements everything and becomes concrete.
All right, let's bring it all home. We're going to quickly summarize the most critical points that you really need to lock into your brain about the abstract keyword. So what's the one number you have to remember? 100%. To become a concrete class, one you can actually create objects from, a child class has to implement 100% of the abstract methods it inherits. There's no partial credit here. It is all or nothing. This table right here is your ultimate cheat sheet. You can't create an object from an abstract class, but you can from a concrete one. An abstract class is all about being a template or a contract, while a concrete class is all about implementation. And the keyword that kicks this whole process off is, of course, abstract. So, as you can see, abstract isn't just a keyword. It's a powerful design philosophy. It forces you to think like an architect, to define the essential, non-negotiable features of your objects before you get lost in the little details. So as you move forward with your coding, I want you to ask yourself, what is the blueprint for my next class? What features are so critical that they need to be part of the contract?